Computers are everywhere. From bustling city streets to quiet outdoor cafes, you'll find people glued to their devices. From our smartphones to our cars, computers have seamlessly integrated into our daily lives. They have revolutionized the way we live, work, and play, making tasks easier and more efficient. But have you ever stopped to wonder how these incredible machines actually work? What goes on inside that sleek exterior? It's like magic, but instead of spells, computers use electricity and logic to perform amazing feats. They process information at lightning speed. In this journey, we'll unravel the mysteries of computers, exploring their history and evolution over the years. We'll break down their complex inner workings into bite-sized pieces that anyone can understand, no matter your background. We'll explore the core components that make up a computer system, from the hardware to the software. From the brain-like CPU that processes instructions to the memory that stores data, each part plays a crucial role. Get ready to discover the fascinating world of bits, bytes, and algorithms, the building blocks of all digital information, and gain a newfound appreciation for the technology that powers our modern world, from virtual reality to artificial intelligence. So buckle up and let's embark on this exciting adventure to demystify the magic of computers. Together, we'll unlock the secrets behind the screens. At the heart of every computer lies the CPU, or central processing unit, often called the brain of the computer. This tiny chip is responsible for executing instructions and performing calculations, making it the driving force behind everything your computer does. Imagine the CPU as a bustling metropolis, with billions of tiny transistors acting as traffic signals, directing the flow of electrical currents. These currents represent data, which the CPU processes at lightning speed, following instructions from software programs. The CPU's power lies in its ability to understand and execute instructions encoded in binary code, a system of ones and zeros that represent the on and off states of transistors. It's like a secret language that computers use to communicate and process information. But how does the CPU actually process this binary code? That's where logic gates come in. These tiny electronic circuits act like digital switches, controlling the flow of electricity based on simple logical operations. Imagine a logic gate as a simple question with a yes or no answer. For example, an AND gate will only output a 1, yes, if both of its inputs are 1. An OR gate, on the other hand, will output a 1 if at least one of its inputs is 1. By combining these simple logic gates in various ways, engineers create complex circuits that can perform arithmetic, compare values, and control the flow of data within the CPU. These circuits form the fundamental building blocks of computation. Now, you might be wondering how all these different components work together seamlessly. That's where the operating system, OS, comes in. The OS is like the conductor of an orchestra, coordinating the actions of all the hardware and software in your computer. From managing memory allocation to handling input and output devices, the OS ensures that everything runs smoothly and efficiently. It acts as an intermediary between the user and the hardware, providing a user-friendly interface and abstracting away the complexities of the underlying system. Popular operating systems like Windows, macOS, and Linux all have their unique features and interfaces, but they all serve the same fundamental purpose: to make computers usable and accessible. Section 5. Memory, remembering it all. Just like our brains, computers need memory to store information. Without memory, a computer wouldn't be able to perform even the simplest tasks. It would be like trying to write a novel without any paper or a pen. There are two main types of memory in a computer: RAM and storage. Each serves a unique purpose and is crucial for the computer's overall functionality. RAM, or random access memory, is like a computer's short-term memory. It temporarily holds data that the CPU needs quick access to, allowing for smooth and efficient operation. It stores data and instructions that the CPU is currently working on, providing lightning-fast access. This is essential for running applications and processing tasks in real time. Think of RAM as a whiteboard where the CPU can quickly jot down notes and access them instantly. When the task is done, the notes can be erased to make room for new ones. However, unlike storage, RAM is volatile, meaning that its contents are erased when the computer is powered off. This is why you lose unsaved work if your computer suddenly shuts down. Storage, on the other hand, is like a computer's long-term memory. It retains data permanently, ensuring that your files, applications, and operating system are available whenever you need them. It stores data permanently, even when the computer is turned off. This makes it possible to save your work, install software, and keep your digital life organized. Hard drives, SSDs, and flash drives are all examples of storage devices. Each has its own advantages and use cases, but they all serve the same fundamental purpose: to keep your data safe and accessible. Section 6. The machine cycle. How computers process information. We've talked about the CPU, logic gates, and memory. But how do these components work together to execute instructions? This is where the machine cycle comes in. It's a four-step process that the CPU repeats billions of times per second to process information. 1. Fetch. The CPU fetches the next instruction from memory. 2. Decode. The CPU decodes the instruction, figuring out what needs to be done. 3. Execute. The CPU executes the instruction, performing the necessary operations. 4. Store. The CPU stores the result of the operation back into memory. This continuous cycle of fetching, decoding, executing, and storing is what allows computers to perform complex tasks at incredible speeds. Section 7. Software concepts, giving instructions to the machine. Now that we understand the hardware side of things, let's talk about software. Software refers to the set of instructions that tell the hardware what to do. It's like a recipe book that guides the CPU's actions, allowing us to interact with computers and perform various tasks. Programming languages like Python, Java, and C++ provide a way for humans to write instructions that computers can understand. These languages use specific syntax and commands to create software programs that control the computer's behavior. From simple calculators to complex video games, software is what makes computers so versatile and powerful. Section 8. Networking basics, connecting computers together. In today's interconnected world, computers rarely operate in isolation. Networking allows computers to communicate with each other and share resources, forming the backbone of the internet and countless other technologies. Imagine the internet as a vast network of roads connecting billions of devices worldwide. Just like cars need traffic rules to navigate safely, computers rely on protocols to exchange data effectively. One such protocol is TCP/IP, which breaks down data into packets and ensures reliable transmission between devices. Another essential protocol is HTTP, which enables web browsers to communicate with web servers, allowing us to access websites and online services. Section 9. Conclusion. The interplay of hardware and software. In conclusion, computers are intricate machines that rely on the seamless interplay of hardware and software to function. The hardware, which includes components like the CPU, memory, and storage, provides the physical foundation. Meanwhile, the software, encompassing operating systems, applications, and drivers, brings this hardware to life, enabling it to perform a myriad of tasks. From the CPU's lightning-fast calculations to the operating system's management of resources, every component plays a crucial role in enabling computers to perform incredible feats. The CPU, often referred to as the brain of the computer, executes instructions at astonishing speeds, while the operating system ensures that all hardware and software components work harmoniously. By understanding the fundamental principles of computer science, we gain a deeper appreciation for the technology that shapes our world. This knowledge not only empowers us to use technology more effectively, but also inspires innovation and creativity. It allows us to troubleshoot issues, optimize performance, and even develop new software and hardware solutions. As technology continues to advance at an unprecedented pace, it's more important than ever to grasp the basics of how computers work. With each new development, from artificial intelligence to quantum computing, the interplay between hardware and software becomes even more intricate and fascinating. So the next time you use a computer, take a moment to marvel at the complex processes happening behind the scenes, transforming bits and bytes into the digital experiences we know and love. Appreciate the engineering marvels and the brilliant minds that make it all possible, and consider how you might contribute to this ever-evolving field.